A conjecture is nothing more than a statement that has yet to be proven true or false.
English vocabulary.
For reasoning, when we're reasoning, there are really two classifications of thought process. The first we're going to look at today is called inductive reasoning. Inductive reasoning is simply making claims based on patterns or other evidence. Okay. If we're just looking at the pattern, you're just looking at what you see and nothing, and that forth, we're just making a guess, a leap of faith based on patterns that we see. That sort of reasoning is called inductive reasoning. Okay.
Like in the first box, there's no vertical lines.
Yep.
In the second box, there's 1, and then in the third box, there's 2. So
Okay.
the third box, the fourth box, there's 3.
So we think maybe the fourth box should have 3 vertical lines strung. Yeah, I agree. That's definitely the pattern I see. So our fourth box we would assume to have 3 vertical lines. So 1, 2, 3. So the pattern was that we should have 1 more vertical line drawn through. Okay. Did anyone else notice maybe a different pattern or a different way to say that?
Well, a different way to say it, on the bottom and the top, there's 1 box on the top and 2 on the top, 3 on the top, 3 on the top.
So then we think that the top and bottom should each have, the first one has 1 box, the second one has 2, the third has 3. So maybe another way to say that same pattern is that in every step we should have that many boxes on top and bottom. Might be another way to say the same pattern. Split it up with an additional line. The fourth step should have 4 boxes in any given row. It's another way to say that pattern. Okay. A counterexample is just a single example where a given conjecture is not true. If your conjecture is true, it always has to be true. So if you can find just a single example where your conjecture is false, then the whole thing is false. Is the only thing you do. So kind of thinking ahead, is it going to be easier to show things are true or easier to show things are false?
Easier to show false.
It's a lot easier to show a conjecture is false. Because all you need is 1 example. If it's true, we have to be able to show that it's always true, so that it works in every single possible case. Okay, so kind of thinking ahead. That's kind of where we're headed. In this case, here's a conjecture that I'd like you to try to disprove. So the conjecture is the following. If you have 2 numbers, we'll call them A and B, and neither of them is 0, then this statement is true. Then A squared minus B squared is equal to subtract them and square that difference. Okay? So find a counterexample. Find an example of 2 numbers, a pair of numbers, A and B, that this formula does not work. Okay? And I'd like you to try that on your own. Experiment. Pick a pair of numbers and see if you can't find any one pair of numbers where this formula is not equal. And try that on your own. Use a calculator, experiment, find a counterexample for this formula. How about A equals 5? Sure, we'll go with the popular one. A is 5, B is 2. It's false. That's one example, and we're done. We're going to also now going to move on to conditional statements. So we're going to combine 2 conjectures together. In particular, a conditional statement, you've seen these in the past, you maybe just didn't know it's called a conditional statement. These are if-then statements. Okay? we'll make a generalization for something, and then we'll make a conclusion based on knowing the first part's true. If and then. And there's actually very specific labels for the if and the then. We'll use the word hypothesis, or what should be true initially. What should be true initially, the if part of a conditional. This is what is always true, and then we'll make a conclusion, or the then part of our conditional statement. If this is true, then we can make a claim. Okay, is our conditional statement. And I wrote a couple of conditional statements on the notes there. First one being, it would be Mr. Fisher will be happy if Michigan beats Ohio State in football this year. That will make me. Okay. This is my first conditional statement. What's the hypothesis? What's the claim that's going to be true first? Paige? If Michigan beats Ohio State. If this comes true, so I'll rewrite this in if-then form. If Michigan beats Ohio State. Once this is true, then what do I know has to follow? Then I'll be happy. Then I'll be happy, or Mr. Fisher, you're not I. Mr. Fisher will be happy. Okay, I can't claim anything about you people, but I know I'll be happy.
I'll be happy.
If Michigan State beats Ohio State, I'll still be a happy person. Believe it or not, I'll still be a happy person. Not as happy, but happy. Okay. All geometry students are math students. So what do we know is true first? All geometry students. This doesn't even have an if or then in it to begin with, but we can write this as a conditional statement. So what is the broad claim that we know that will be true first? So if students are in geometry, or you're a geo student, you can rephrase this however you choose, like if you're geometry, if a student is in geometry, however you want to say it. The hypothesis is the geometry student, because every single person that's in geometry, we can conclude then what? Then they're math. Then you're a math student. To negate, then I want the opposite statement. And what's the easiest way to make something its opposite? If I say, yeah. Not. So the book was long. What's the quickest way to negate this? The book was not long. The cat is black. What's the quickest way to negate that? The cat's not black. We're probably not going to use no double negatives. Cat is black. If we have a conditional statement, there are three very important what are called related conditionals. Okay? There are three very important related conditionals. They're a very specific pattern to rewrite a conditional statement. In particular, if our original statement is thus, if a man lives in Dexter, then he lives in Michigan. Okay, this village of Dexter. The converse of a statement is we're going to flip the hypothesis and conclusion. So if I ask you what is the converse of a statement, we'll simply flip the hypothesis and conclusion. It may be true. The converse might be true. It might be false. Don't care. You can still write the converse. Whether it's true or false, we can still write it. So in particular, the converse of if a man lives in Dexter, then he lives in Michigan, would be if a man lives in Michigan, if live in Mich, then lives in Dexter. Okay. Don't care if it's true or false at the moment. We'll go back and analyze whether it's true or false in a second. But we're just going to go down and write these new statements we can make. Okay? We can make a converse. We can flip hypothesis and conclusion. We could write the inverse of this original. The inverse would be negate both hypothesis and conclusion. Negate both. Negate both of them. So then I could say, if not live in Dexter, then not live in Michigan. Writing the sentences. The last one is a contrapositive, and that's doing both of these. So we'll flip and negate. So we'll flip and negate both. So we'll do converse and inverse. So contrapositive would be if not in Michigan, then not in Dexter. This is a true statement. Okay? Is the converse true? If you live in the state of Michigan, then you live in the village of Dexter.
False.
It's true only if it's always true. If it's false, then we can provide an example where it's not true. So if you say it's false, is there an example where you live in Michigan but not in Dexter?
Yeah.
Yeah, what's a counterexample? Saline, Ann Arbor, Detroit, Lansing, Muskegon. There's a lot of examples. You only need one. This is a false statement. Is the inverse true? Is the inverse true? If you don't live in Dexter, then you don't live in Michigan. Can you provide a counterexample?
Living in Ann Arbor.
Same thing, Ann Arbor. Not in Dexter, but you are in Michigan. Okay? How about the contrapositive? If not in Michigan, then you're not in Dexter.
Yeah.
That's true. You can't possibly be in Dexter if you're not in the state of Michigan.
But you could be in like.
Notice which ones have the same, what are called truth value. Which ones are what are called logically equivalent? The original is true. And Becky, what other one's true?
The one where you flip and negate both.
And what's that called?
The
Contrapositive. If two statements have the same truth value, if one's true, then the other is always the same. Then they are called logically equivalent. Okay? So at the bottom of your notes, I have a nice little thing here. In general, the original and the contrapositive are logically equivalent. If one's true, the other's true. If one's false, the other's false. They will always have the same truth value. Similarly, the converse and inverse have the same truth value. They're both logically equivalent. If the converse is false, then the inverse also will be false. If the converse is true, then the inverse also will be true. These two are linked. They are logically equivalent. These two are linked. They are logically equivalent. We have one special case where we're going to look at a special case where what happens if both the original and the converse are true. That's if your statement fits that description, then it's called a biconditional. A biconditional is just a statement or a conditional statement, more specifically, whose converse is also true. And maybe I should have said a true statement whose converse is also true. Well, signals for a biconditional, if it's a biconditional, then we can rewrite it in what's called if and only if form. We can, if it's a biconditional, if both its original and converse is true, then we can rewrite it connecting the hypothesis and conclusion with if and only if. And if you're really lazy like me, then you can abbreviate if and only if as if. If you're really lazy and you don't like writing if and only if, you can go if. Is fine too, is the official abbreviation. Okay. The converse of this statement, or flip the hypothesis and conclusion, would be if two lines are perpendicular, then what's true? If they're perpendicular, then they form a right angle. The converse would be if two lines are perpendicular, then they form a right angle. Is the converse true?
Yes.
Hopefully you remember the definition of perpendicular lines, which is exactly that they form right angles. Okay? That's the definition of perpendicular. This is a true statement as well. Since the original is true, and the converse is true, then this is what's called a biconditional. And if I rewrite this as a biconditional or in biconditional form, I do the following. I would take the hypothesis, the conclusion, and connect them with if and only if. So my biconditional might be two lines are perpendicular if and only if they form a right